What's going on, everyone, and welcome to day 27 of our Juniper Networking series. In today's video, we will be doing a video on why we should not be using Telnet within our enterprise networks. Telnet sends our information over the network using TCP port 23. And Telnet allows us to connect remotely to our network devices over the network and control them. But Telnet sends all of this information over the network in plain text format. So if someone is on our network using a network analyzer such as Wireshark, and that is the application we're going to be using in this exact video, they will be able to see our passwords, our commands, and everything else. In this particular video, we're going to be looking at the password. So instead of using Telnet in today's networks, we should be using a more secure protocol which uses encryption such as SSH. And we're going to be looking at that protocol as well within this video. So we're going to take a look first at our information being sent over the network in plain text with Telnet. And then we're going to see the encrypted version using SSH. So if they're using that same network analyzer and our information is being sent with SSH, the only thing they're going to be able to see is the ciphertext. So let's go ahead and hop into this video now on why we should not be using Telnet. Let's get into it. All right, so we have our freshly booted switch up right now, and we have plugged into the console port because we want to lay out the requirements that we're going to do for this video first. So the first thing that I want to do is enable SSH and Telnet. After that, we're going to have to create a user on this switch because as I was practicing for this lab and getting this lab ready, I realized that you cannot log in as the root user when using Telnet on this particular switch. Now, I don't know if that is something that Juniper has across all of their devices for security purposes. I think that is a very cool feature though, but we have to create another user outside of the root user because we're going to be using Telnet in this video. After that, we're going to connect our management interface to our live network so it can get an IP address from DHCP. And then whatever IP address we are given, we're going to use that IP to connect to our switch over the network using Telnet first, and then we're going to look at the encrypted version of SSH. So let's go ahead and start out by enabling SSH. So let's do a set system services SSH, and we want to do and allow for the root user login. So let's do root login and let's do allow. If we do a context sensitive help, that should be it. So now let's go ahead and, well, I wanted to show you guys, you can also deny password as well if you want to, but like I said, we want to do the allow. All right, so let's go ahead and hit enter there. And the next thing that we want to specify is going ahead and allowing Telnet. So we need to do a set system services. Let's specify Telnet, and let's go ahead and hit enter there. And now let's go ahead and specify our user. So let's do a set system login, and we want to do a user. We want to name the user by the name of Ben. All right, and we want to do a user ID, and let's just give it an ID of 5,000. Let's just say 5,000. All right, let's do the class as a super user. And the last thing we want to specify is the authentication. So we want to do an authentication of a plain text password. And let's go ahead and hit enter here. And the password we want to set is password with the number 1. So let's do password 1, and let's do password 1. All right, so our password has been set. So now let's go ahead and connect our management interface into our switch so we can get that IP address from DHCP. All right. So now if I do a run show interfaces terse, we should have an IP address on our ME0 interface. Let's go down and see. So on our ME0 interface, we do have an IP address of 192.168.2.8/24, and that IP address was given to us through DHCP. So now let's go ahead and pull up Wireshark and connect to this IP address of 192.168.2.8 through PuTTY. Alright, so we have Wireshark pulled up here now. We have a lot of different interfaces on my computer, but for this lab, I am going to be using the Wi-Fi connection. And I want to do a filter. Well, I'm going to be blocking out everything that's going across my network right now because I do not want you guys to see that. This is my live network, but I want to do a IP dot address, and we're going to specify that address that we were given on our interface, so we only see the switch information. That's all I want you guys to be able to see. All right, so we specified the 192.168.2.8/24 address. So now let's go ahead and pull up PuTTY and try to connect to our device via Telnet. All right, so we have PuTTY pulled up here. Let's go ahead and type other, and we want to connect to 192. Oh, did we commit these changes? Before I do anything, let's go back to PuTTY and let's do a show pipe compare, because if I didn't commit these changes, we are going to be in a handful of trouble, and we did not commit. So let's do a commit and quit. I just realized that. It's a good save. Okay, that commit was successful. Now let's hop back into where we were at. So let's pull back up PuTTY right here, and we want to do the IP address of 192.168.2.8, and we're going over Telnet over port 23. So let's hit open here, and we can just see a lot of Telnet information being sent. Okay, you can see that on our Wireshark capture. Let's pull over our PuTTY connection, and let's try that root login. Remember, I told you that root did not work for this switch. So if I type in the root authentication password, this is the right password, but it's just not going to allow the login. And I think that is a security feature, which I really like for Juniper, because we should not be using Telnet to even begin with on our network. But now let's go ahead and specify the user of Ben, and let's specify the password of password1. And now you guys can see we are logged into our switch using Telnet. So now if I stop this packet capture for Wireshark, and we take a look back through some of this output, let's see what we can find. Okay, let's see what we can find. So we see that the letter C right here was sent as a data packet. Let's see what we can find. Going back through this output just to see if we can see that password that was sent. Okay, so we can see where we were logged in at. This is the login that you get after you log in as a user. So we see that that output was sent in plain text. What else can we see? Keep going up. Oh, so we see the number 1. So this may be our password sent in plain text. Is it? We got the number 1 right there. We have the letter D. We have the letter R, O, W, S, S, A, P. So if someone was using a network analyzer and they seen this information being sent across the network, they will be able to see our password in plain text. And this is why we do not use the protocol of Telnet. You can see my password was sent in plain text. So we have the data of P, A, S, S, W, O, R, D, and the number 1. So this password was sent across the network in plain text with no encryption. So let's close down that Telnet connection, because we should not be using this inside of our networks. Let's close down. Let's exit this connection. We do not want that up anymore. Let's pull PuTTY back up. So we want a new connection for PuTTY. All right, and this time we're going to specify SSH here over port 22, the more secure protocol. Let's turn back on our Wireshark capture. Let's continue without saving. All right, let's pull PuTTY back up, and let's connect to 192.168.2.8 again. And we'll use the SSH this time. So if I do an open, we can see that we now have SSH v2 as our protocol being shown. So let's go ahead and log in as that same user. Let's say a Ben, and let's do a password of password1. All right, and we're logged back in now. So let's close this capture. And now if I go through all of these packet captures, we can see that our information is being encrypted using AES 256. So that is the algorithm that is being used, the AES algorithm. So now if we go back through all of these captures, we're not going to be able to see any type of password being sent. You can see the server sent an encrypted packet. So if somebody was to try to intercept this information, all they're going to get is this ciphertext right here. So they cannot see anything that's going on our network to further be able to use for any type of attack. So this is why we use SSH version 2 within our production networks. Telnet was created back in the day with, I believe, ARPANET. So it's a very, very old protocol. But just going through all of these packet captures that say SSH version 2, we're not going to be able to see any type of password information being sent across our network. So as a result, you want to use this secure protocol of SSH. So I appreciate you guys for tuning in to day 27 of our Juniper Networking series. I hope to see you in day 28. But until then, peace out.